project, also called Gutendex. It's a project where you can search for books in the catalog of Project Gutenberg. You can see the text, you can rate those books, and you can see information about the sentiment of those books, as well as view other books that are clustered similarly to that book. So um, one of the cool things about this project also is, there's a user system, so you actually can't see any of these pages unless you are logged in as a user. So if I try to go to this page, it's going to redirect me to the login page, which is nice. You need that for a rating system, and so even though I never actually got around to doing a recommender system, like providing book recommendations. It's pretty neat that the user system is there and the rating system is also there. So to start, this is part of the existing project that I had done previously, but this whole thing has a built-in system where you can search for query terms and you get a list of books that have text within them. So we're actually working with a subset of Project Gutenberg. I think there's only like 270 books that I have in here. Anything more, like getting even beyond 100 gets a little crazy with clustering and creating the documents. So for my regular old MacBook Pro, I just decided to do 200 or so books. So there, we see if we search for something, we get this list again. This whole list view existed before. But now we see, okay, we clicked on a book, and here's what's new. Yes, you can see the text in the book. We selected Alice in Wonderland, but what's cool is we have this new rating system where we can rate the books. So here we see, because I'm logged in, it remembers that I've rated Alice in Wonderland as a 5. And we also see this new information about the sentiment of the book. We have positivity, negativity, neutrality, and compound. Compound is just a metric between -1 and 1. That's an aggregation of all of the positivity, negativity, and neutrality. And so we see that this book is ever so slightly positive, but mostly neutral. And then that makes sense. The positivity is slightly higher than the negativity. Um, and also implemented as part of this is these books are all clustered. So now the user has the ability to see, okay, I want to see other books that are clustered similarly to Alice in Wonderland based on the words within it, or based on the tokenized representations of the words. Tokenized representations are, taking all these words and shortening them to, the root of what the word represents. And the one I thought was actually pretty cool was clustered by polarity. And so I clustered. The default setting is into 20 different clusters. So here we see these are the books that are found to be similar to the words in Alice in Wonderland. Um, and we can see books that are similar to the tokens in Alice in Wonderland. Again, both of these should be, words and tokens should be similar, but they aren't always. But again, the one I found interesting was polarity, because these results are not all the same. And I find that the polarity books almost have, I don't know how to describe it, but the books clustered by polarity have a little bit more serendipity to them. You don't exactly expect some of these books to come back, and yet they might be a similar read to Alice in Wonderland. And so the cool part about the system all happens kind of behind the scenes. So if you notice, that clustering actually happened really fast, and that's because the clustering actually isn't happening in real time. When you click this, all that information is persisted in the database, as is the positivity, negativity, neutrality, and compound information. So if we go into the database, we've cracked open the project, and here is the bread and butter. It's this list view and this detail view. Detail view is information about the specific book. The list view is how we're generating that list. And so we see that we've stored this cluster in the database, and we're getting the cluster of the book that we passed from that detailed view, and then we're getting a list of books that are clustered similarly. And as I said, the default was 20 clusters. And how did we get these clusters to begin with? Sorry, this is the wrong file. We have this clustering management command, and in it we go through and we grab a whole bunch of books. We're getting the average um, positive, negative, and neutral um, ratings of each book, and we are going through and we're doing um, looking at the TF-IDF vector, the word vector, and even the polarity vector. And we're pulling that information that's already been stored in the database, and then we're creating these clusters. And I just created 2, 5, 10, and 20. We're using k-means, and we're looping through all of these books, and we're saying, okay, hey, this book is stored in this cluster. And if we look at the models, there's a whole bunch of new models. Book was existing. I mean, we see we have like author in here. There's a whole bunch of metadata stored about each one. And there are all these nice helper methods, creating a sparse TF-IDF vector, creating a word TF-IDF vector. I added a whole bunch. These are like cosine, sine, Jacquard distance. But I added these new ones as part of this project for positivity, negativity, neutrality, and compound. Just nice helper methods for going for the book, getting for each book getting these metrics. And so we see that the positivity, negativity, and neutrality is actually an aggregation of all the sentences in the book. We're getting the average positive value for all the sentences, the average negative value, the average neutral value for all the sentences, and the average compound. And we can see that these books, we have all the words for each book stored in the database, but we're actually also storing sentence information. So for every sentence in every book, we have the index of that sentence. So the first sentence is index 0, so on and so forth. But we also have the positivity, negativity, neutrality, and compound data. And so again, when you're viewing this book on the website, these metrics are actually the average of all sentences in Alice's Adventures in Wonderland. And again, here's the rating information. But I mean, there are a handful of management commands. So this is the cluster management command. So once you have all that information stored, you can cluster the documents. But there's a management command for pulling the books, the catalog information from Project Gutenberg. There's a management command for taking those books and then getting the text for those books. There's a command for taking the books and tokenizing them and storing that tokenized information in the database. The same for getting the sparse word vectors and storing them in the database. That's this management command. There's a command for clustering. Oh goodness. And the book categories. Pulling books of a specific category. Again, and then lastly for creating the sentence polarity. And so again, basically this command goes through for just the polarity, for example. It goes through and gets all the books that have text, and it uses this sentiment intensity analyzer that's pulled from the Natural Language Toolkit. And so again, this guy goes through every sentence in every book. It stores the index of that sentence as well as a bunch of polarity information. And so again, this is neat. Instead of having to do all this stuff in real time, we have this nice system that's set up to calculate all of this information, store it in the database, and then for a given user, you can just search this information and get it at really fast speeds. So you wouldn't be able to have a system that was able to get all books clustered by polarity that quickly. It just wouldn't be possible. So that was kind of the work done by this system. So anyway, thanks for watching. I hope you enjoyed, and have a good day. This was a great class. So yeah, it's been a good semester. Thank you for everything. Hope you enjoyed.